So our goal for this was to understand this graphing form of a parabola. This y equal x squared is what you see physically here. That is your basic parabola, okay? And for your basic parabola, what you'll notice is 0 squared is 0. You've got a point here at 0, 0. 1 squared is 1. So I have a point at 1, comma 1. If I was to go out 2, 1, 2. 2 squared is 4. 1, 2, 3, 4. That is the points that are on this basic parabola. On the other side, if I go out -1, when I square in -1, I get 1. So that's why I'm here at -1, comma 1. If I square in -2, -2 squared is 1, 2, 3, 4. So that's how I get all of these points. I want us to be able to accurately, sometimes they're going to ask for a sketch, but I want us to accurately know how to graph each of these as a parent function and if it's being moved. So when we're looking at this y equal a times the quantity x minus h squared plus k, we want to understand what each of the pieces does. This a is called the stretch. So if I move that a, so it's a is equal to 1 right now. That's your basic parent equation. The stretch is not being changed at all. As I make this bigger, so I'm making it a bigger number, you see that it's making this thinner. We call that vertically stretched. So any a that is bigger than 1 is going to make it skinnier, narrower, vertically stretched. If I go to 1, any number less than 1, okay, but greater than 0, so if it's less than 1 but greater than 0, it's going to make it wider. The reason that is so, for example, if I am right here at 1, 1 squared is 1. If my a is a 0.1, what that means is after I square 1, I'm going to multiply that result by 0.1. And so I'm really 1/10 as high as I should be. That's why it's low and it looks like it is wide. If I went out 2, 2 squared is 4. Then I would be timesing it by this 0.1. So I would be at 0.4. Okay, you can see I'm not even at a half yet. That's why it is wider. It's really not getting as high as fast. But if I'm at greater than 1, so let's say I'm at a 2, okay, if I go out 1, 1 squared is 1, times that by 2, 1, 2. If I go out 2, 2 squared is 4, times that by my stretch of 2, that's going to be an 8. So here's 5, 6, 7, 8. That's how we can graph a basic parabola. Now, when my a, let me move this. When my a is negative, then it's going to flip, okay? And it's going to make it be upside down. We say open down, where this is open up, okay? That's what your a does. Your h, as I move this h, it's going to move it to the left or to the right, okay? That's what's going to happen here. Now, what you want to understand and be careful with is this is a negative h here. This is x minus h. So what I want you guys to understand, and let me just grab this here. I want you guys to understand is when we are doing this, and we are looking at this x minus h, what's going to happen when we were moving it, it seemed like, oh, if it was positive, we moved to the right. And if it was negative, we moved to the left. And that's a little deceiving because what you need to remember is when I moved it to, if my h was a 5, I was really doing this. Okay, if my h was a 5, it was really a minus, and then my h was a 5. And then you look at this and you ask yourself, well, what makes x minus 5 0? That is going to be a 5. So what would happen is this graph is going to be moving to 5, not because of my h being, I want you to understand that it's always the opposite of what's here. Does that make sense? So if that is a minus 5, I am moving to the right 5. And then my parabola would be right here. 1 squared is 1, and 2 squared is 1, 2, 3, 4. And same on the other side, and that would be my parabola, okay? If I had y equal x plus 5 squared, okay, where it's a plus 5 in my parenthesis, negative 5 makes that 0. So my graph's actually going to move to the left. 1, 2, 3, 4, 5. And then I'm going to have 1 squared is 1, and 2 squared is 1, 2, 3, 4, as long as my stretch is not being changed. And that would be my graph. So you want to understand that if I have an x minus 5 in my parenthesis, whatever makes this x minus 5 0, that's the direction your graph is being moved. So what makes this 0 is a positive 5. Here, what makes this 0 is a negative 5. Okay. Then when we're looking at the k, as I move it, it's going to move my graph up if it's a positive, or down if it's a negative. That's what's going to be happening with this. Okay. So what I want us to do is on the paper, let's jot down what a basic parabola looks like. Okay. We'll do it together. What the equation is, and then we're going to try doing some of these. So let me just get so for this is going to be basically parabolas, okay? Parabolas. So for this, our parent equation, okay, our parent equation for a parabola is y equal x squared. That's our basic graph. And our vertex for that is going to be 0, 0. Okay. Now, when I go and graph this, I'm going to draw my graph right here. I don't need to go below the x-axis for this because when I square something, I get a positive, but I'd like us to get up to at least a 9. Okay. So make sure you can get up to 9. Okay. And this is my x-axis. This is my y-axis. So when I'm doing this, I'm putting in a 0. And when I put in a 0, 0 squared is 0. So I have a point at 0, 0. When I put in a 1, and let me just make this a little bigger for us. I know the grid might be a little hard to read on that screen over there. Maybe if you're closer, it's okay. So as I go out 1 squared is 1. As I go out 2 squared is 1, 2, 3, 4. Okay. So all I did was at x being 0, I did what the equation asked me. I squared my x. 0 squared is 0. Here I went to 1. 1 squared is 1. Here I went to 2. 2 squared is 1, 2, 3, 4. Then I'm going to go out 1, 2, 3, and 3 squared is 9. So this was 4, 5, 6, 7, 8, 9. Now, when I go to the other side, a -1 squared is also a +1. When I go to -2, a -2 squared is also a +4 like the other side. A -3 squared is also a +9. And then I'm going to connect the points. And there's my parabola. I'm going to make this a little lighter. Okay, and there's our parabola. That is your basic parabola. If you can square a number, you can graph a parabola. Okay. Now, when I am graphing a parabola, what's going to happen, and I'm just going to grab this for a second. You guys obviously can't do this on your paper, but I'm just going to grab this. And what happens is it's the same parabola, but if let's say, I'm going to jot this down for a second. You don't need to write when I'm writing. If I have y equal the quantity x plus 2 squared, well, what makes the x plus 2 become a 0? That would be a -2. So what that means is this parabola would move 1, 2, and that's where that parabola would be. It would be the exact same parabola. I would still have 1 squared is 1. And if I move from here, 2 squared is 1, 2, 3, 4. And if I move from my vertex and I go out 1, 2, 3, 3 squared is 9. Those values are still going to be the same. It just gets shifted. Okay, it's translated. Okay. Now, if I have my graph and instead I am minusing 2 from that x squared, what that's going to do if I come to this, okay, and I have it right here where x squared was, I am literally going to move it down 1, 2, and my vertex would be sitting down at 0, -2, but from my vertex, I still have 1 squared. When I go 1 away is 1. When I go from my vertex 2 squared is 1, 2, 3, 4. When I go 3, 1, 2, 3. 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. So as long as you know where your vertex is, you are going to be always doing the same situation here where you're graphing the parabola and it's the same as a basic parabola. We're just translating it right now. So our general equation is going to be the following. And it's important that you understand how this moves because all of our graphs that we're going to be learning a lot, all move in a similar manner. So our general equation is going to be y equal a times the quantity x minus h squared plus k. That is your basic general equation of a parabola. I'm just going to move this off so we can see that. Now, when we're talking about this, some things you want to make sure you recognize, your vertex is going to be whatever makes that parenthesis 0. Since this is an x minus h, what would make that 0 is a positive h. So we usually say our vertex is h comma, and then if it's a plus k, minus k, whatever is being added or subtracted, that is your y coordinate of your vertex. Now, the other things that we need to understand, a is equal to our stretch. Okay, that's what our a is. And our a is going to have a couple different characteristics that we need to understand. Basically, if our a is greater than 0, which basically means positive, it's going to open up. Okay, so you have an open up parabola automatically. If our a is less than 0 or negative, and I'm saying greater than 0, less than 0, because sometimes books will have it written in that form and not necessarily say positive or negative, it's going to open down. It's going to be upside down. Okay. Then, besides it being positive, knowing it opens up, and negative, knowing it opens down, we also have the A changing it to being wider or narrower. So if your A in absolute value, the reason I'm putting it in absolute value is because if it's a positive 2 as a stretch or a negative 2, they both will be the same width, but one will open up and one will open down. Okay. So if your absolute value of A is greater than 1, that is going to be narrower. What the book is going to call it is vertically stretched. That's how they're going to term it. And then if your absolute value of A is somewhere between 0 and 1, some fraction or decimal between 0 and 1. And I don't want to say just fraction or decimal because 1.5 would be greater than 1. Okay. Or 3 and 1/3 would be greater than 1. Those would both be narrower. But if you have a fraction or decimal between 0 and 1, whether it's positive or negative, that's going to be wider, which means it's going to be vertically compressed. That's how they talk about it. Okay. So your A is going to determine if it opens up or down. Your A is also going to determine if it's narrower or wider. Depending on if the number in absolute value is greater than 1, it's going to be getting higher faster, so it's going to be narrow. If it's between 0 and 1, it's going to get higher slower, so it's going to be wider. Can I move it to that? Anyone copying anything above that? Jared, did you get everything before that? Okay. So the other thing we have here is our h. So the part that has an x minus h squared, or you could have an x plus h squared, whether you are having an x minus h or an x plus h. Whatever makes that 0 is the direction you're going to be moving. So if it was x minus h or like x minus 5, 5 would make it 0. So the x minus h is going to move right h, because a positive h would make x minus h 0. X plus h is going to move left h, because a negative h would make that 0. And then we're also going to talk about a positive k versus a negative k. So if you have a plus k at the end of your equation, that means you're going to move up k. If you have a minus k, you're going to move down k. And that's going to be true, all of these, for every type of graph we talk about. They're all going to be moving in the same way, but based off of their parent graph. Okay. Okay. So let's say they want us to do an example. So let's say, for example, They want us to graph y is equal to negative, and I'm actually going to make the number smaller than we had in the book so that we don't have to take up as much graph paper space. Let's say we have negative x minus 3 squared plus 2. Let's say that's what they want us to graph. So what is the vertex for this? What is the vertex for this? So our vertex is going to be 3 because that makes the x minus 3 0, comma 2 because of the plus 2. So now I'm going to draw my graph. I am going to go to 3 comma 2 because that is my vertex. So I'm going to go 1 2 3 comma 1 2. That is my vertex. And actually I should shift this a little, shouldn't I? What am I doing wrong? If that's the bottom of my page, should this open up or down? It's going to open down. So let me just move that. Okay. So let me, oops, I didn't want that in red. So I am going to want to have more below. And so I'm going to go 1 2 3 comma 1 2. Make it a different color so we can see it. Okay, so that's 3 comma 2. And now, since my stretch is a 1, it's actually a negative 1. I am just, from my vertex, going to think 1 squared, 2 squared, 3 squared, and that's how I'm going to think about this. So if I go out 1, just going to get this hand for a second. If I go out 1, 1 squared is 1. I times that by negative 1, I'm going to be down here. Okay, so again, I went out 1, 1 squared is 1. I times it by the negative 1, so I'm down at 1. It's going to be the same on the other side. Okay. From my vertex, I'm going to go out 1, 2. 2 squared is 4. But because of that negative in front, I'm going to go down 1, 2, 3, 4. And same on the other side. And then if I went out one more time, 1, 2, 3, 3 squared is 9. I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so again, I went out 1, 1 squared is 1, so I went down 1. I went out 2, 2 squared is 4, but because of the negative, I went down 1, 2, 3, 4. I went out 3, 3 squared is 9. I went down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then I'm going to connect this. And there's my parabola. Okay. And I want to do one with an actual number in front. Okay. So let's say I do a second example here. And I do y equal 2 times the quantity x plus 3 squared minus 4, something like that. So y equals 2 times the quantity x plus 3 squared minus 4. So I am going to first start with the vertex. And my vertex, if I look at this, that plus 3, that means what makes that 0? -3. And then it is a minus 4. So my vertex is going to be at -3, -4. My parabola is going to open up because of the positive 2. So let me draw my graph so that I can get down to a -4. So I can drag this down a little more. Make this, just going to drop it down a little bit. Thought I was at the bottom of my page. So I'm going to go to -3, -4, 1, 2, 3, 1, 2, 3, 4. Okay, that's going to be my vertex. And let me just jot that down. That is -3, -4. That's that vertex. Then I'm still going to be from my vertex going out 1 and squaring 1 and going out 2 and squaring 2 and going out 3 and squaring 3 because this whole thing is x squared. But I have a 2 in front, which means after I square 1, I'm going to double it. After I square 2, I'm going to double it. After I square 3, I'm going to double it. So if I go 1 away from my vertex, 1 squared is 1. I double that, I'm going to go up to 2. And I'll do the same on the other side. And when I say up to 2, I'm going 2 up from where my vertex height is. So again, I went over 1. I'm going to zoom for a second. I went over 1. 1 squared is 1. So from here, instead of going up 1, because now it's narrower, I times that by 2, and I'm going to go up 2. I'm going to go out 1, 2. From my vertex, I'm going straight across 2. 2 squared is 4. I'm now going to times that by 2, so I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the other side is going to be the same. So again, I went out 1 squared, which is 1. I doubled that, 2. I went out 2 squared, which is 4. I doubled that, 8. If I go out 3 squared is 9. If I double 9, I'd have to go up 18. And I don't know, we might not have room for 18. Okay. And then I'm going to connect my points. And there's my parabola. Okay. So let's take a look at the homework question 18. Okay. Understanding what this is. And 18 is actually what 13 and 15 from the classwork up there is about also. So if I talk about 18, that's the same idea. So on 2-18, we have a situation where we have a, we're shooting water from that barge onto that burning building on a pier. And we're trying to figure out the water flow here. So we're really trying to figure out this right here. That's what we're trying to figure out. Okay. They do give us an E tool here. These are always hyperlinks. You can always click on them, but when you're clicking on it using Cami, you got to come to the arrow. And so they do give us a hyperlink here, and you can move this however you want. So you can center it so that the center of it is at the origin, or you could move it so that it starts at the origin and goes out. Does that make sense? You can do it either way. Okay. So I could put this anywhere on this and then try to graph it. So on this, if we're graphing it, let's say I do this one where I start at 0, 0. Okay. So let's say I start at 0, 0. And then I have my parabola like that. Again, I could have had my vertex be on the y-axis, or I'm just choosing right now to start at 0, 0. So I am starting here at 0, 0. If we are looking at this, let me move it for a second. We see that the water shoots how far? 120. So that means this point's going to be 120, 0. That's what that's going to be. Now, our vertex is going to be, do we agree, in the center of this parabola? How high is that vertex up on the y-axis? 50. So I know that this is going to be something, 50, because in the picture we saw that it was 50. How can we figure out that x coordinate? What is the x coordinate going to be? No, no. Well, why'd you say 60? Okay, so we know that we have 0, 0 and 120, 0. So one x-intercept is 0, one x-intercept is 120. Halfway in between would be like our line of symmetry. So that's where our vertex has to be halfway in between. So this is going to be 60. So now if I'm doing this and we want to write an equation, I'm going to start it up here and then I'm going to write it down where it says equation. It is going to be y equal a times x minus h squared plus k. So I know it's going to be y equal a times something squared. What am I going to have in that parenthesis if my vertex is 60, 50? X minus 60. Exactly right. And what am I going to put outside of this? Plus 50. Now, I almost have everything. The last thing I need to do is find the A, find the stretch. So to find the stretch, you're going to use one of the points that is on your graph, but never your vertex. Your vertex is not going to help you because your vertex is not being changed by the stretch. Every other point's being changed by the stretch. So either you're going to put in 0, 0 for your x and your y, or 120, 0. I probably would prefer to do the 120, the 0, 0 than the 120. So I'm going to be putting in 0 here and 0 here, and then working this out. And when I do this, 0 minus 60 is a negative 60. A negative 60 squared is 3,600. A, because it has an A timesing with it. Plus 50. Now I solve. So I'm going to minus 50 from both sides. I'm going to divide both sides by 3,600. And that is our A. Now, if you want to simplify that fraction, you can simplify that fraction, okay? But our final answer, let me just kind of jot it down here, is going to be y equal, again, I'm just going to leave it right now as negative 50 over 3,600. You can reduce that. X minus 60 squared plus 50. Then I know they ask us about domain. I'm just going to keep it on this section of it. The domain is your x's. In this situation, your domain goes from 0 to 120. That's where it goes. Your range goes from 0 to 50 in this situation. Okay, so hopefully that helps you out a little bit. No homework this weekend.